Crash Course Instrumentation, Episode 5, Resistance, Current, and Circuits. Welcome back to Crash Course Instrumentation. In this episode, we're bringing everything together: voltage, current, and resistance, to understand how energy actually flows through a circuit. This is where theory meets real-world instrumentation. Let's start by talking about current. What is it exactly? In simple terms, current is the flow of electric charge. It's measured in amperes, or amps, and it tells us how many charges pass a given point in a circuit per second. You can think of it like water flowing through a pipe. The more water that passes by per second, the greater the flow rate. In a circuit, the more charges passing per second, the higher the current. Now, what makes the charges move? That's where voltage comes in. Voltage is the electric potential difference between 2 points. It's like the pressure pushing water through a pipe. The higher the voltage, the greater the push on those charges. So if voltage is the push and current is the flow, what slows things down? That's resistance. Resistance is anything that resists or restricts the flow of current. It's measured in ohms, and it represents how much the material or component resists the movement of charge. Let's return to our water analogy. Imagine a narrow section of pipe or a clog. The flow is restricted, so even with pressure, less water comes through. In a circuit, resistance acts the same way. It controls how much current flows for a given voltage. This leads us to one of the most important relationships in all of electrical engineering, Ohm's law. Ohm's law and says V equals Ix, R, where V is voltage, volts. I is current, amperes. R is resistance, ohms. This formula tells us that if you know any two of the values, you can calculate the third. It's the foundation of how we analyze and troubleshoot circuits in instrumentation. Let's put this into practice with an example. Say you have a 12-volt battery and a resistor of 6 ohms. Using Ohm's law, we calculate the current. I equals V, R equals 12V. 6 went equals 2A. That means 2 amps of current are flowing through the circuit. If the resistance increases to 12 ohms, the current drops to 1 amp. More resistance equals less current, just like a tighter pipe slows down water. In real instrumentation systems, resistance tag isn't just found in resistors. It's everywhere, in wires, in sensors, in the environment. High resistance connections can lead to voltage drops that affect signal accuracy. That's why we care about proper wiring and tight connections. There's also power to consider. How much energy is being consumed or converted in the circuit. Power is calculated using P equals VXY. So in our example, P equals 12 EX2, A equals 24 watts. That's the amount of energy being delivered per second, whether it's turning into light, heat, or motion. Understanding how voltage, current, resistance, and power interact is the key to building and troubleshooting any electrical or instrumentation system. So let's recap. Current is the flow of charge. Voltage is the push that moves the charge. And then resistance restricts the flow. Ohm's law ties them all together, VXIXR. And power tells us how much energy is being used, P equals VXY. All these ideas come together in every circuit, every sensor, every controller you'll use. Mastering them means mastering the electrical foundation of instrumentation. Thanks for joining us on this episode of Crash Course Instrumentation. Up next, we'll explore how to visualize these relationships using graphs and plots, and why that matters when you're analyzing signals and system behavior. Don't forget to like, subscribe, and share with your fellow techs and students. See you next time.